Hi, I'm Nimrod from BDN Automotive, and now you're watching the third episode of the BDN combustion analysis tutorial video series. In today's video, we're going to talk about two things. First of all, my colleague Balint will talk about how engine calibration affects the cylinder pressure trace. And secondly, what everyone has been waiting for, we'll go on the dyno and we will tune a car with the use of the CA6 combustion analyzer. Stay tuned.
We were driving our car at the dyno at the constant engine speed of 2,500 RPM at full load with 4 different ECU set points. There were 2 lambda and 2 ignition advance set points. One lambda set point was 0.81 and the other was 0.93. And the ignition advance was retarded at the 2 lowermost points by 6 degrees compared to the first measurements. At the first measurement, it is clearly visible that at the lambda 0.93, some slight knock was occurring compared to the 0.81. At the lowermost pictures, the ignition advance was retarded compared to the first ones. That results much lower cylinder peak pressure and also later cylinder peak pressure location. What is clearly visible from the images that the area under the pressure curves are much lower, that are resulting lower IMAP and torque values for those cycles.
After seeing the effects of ECU calibration on a single engine operating point, let's go on the dyno and do some sweeps. First of all, important to mention that what we have done is a simplified version of tuning because we have a fixed target lambda of 0.85 for all the measurements. The reason of this is that we would like to only show you and determine how this device can be used and can be helpful during the tuning session on the dyno, but we're not doing a full dyno session now. So, the first measurement has been done with turned on ECU knock control. So Balint, what do you see on the results?
Yes, what is visible here, that between 3 and 4,000 RPMs, that is basically the torque peak of the engine, the combustion is happening a bit too late, because the MFV50 value is around 15 to 20 degrees. And in addition, at that region, the knock peak is not significant. So what could be done to improve the performance in that area is to apply a bit more ignition advance. And then let's see how things are going.
Correct. I completely agree with you. So what we have done for the next measurement is we've added 2 degrees of ignition from 3 to 4,000 RPM. Let's see what comes next.
Yeah, as it is visible now, situation is getting better. MFV50 is going down in the region of 15 degrees compared to the previous slides. And what is also visible here is that near the red line, the MV50 is going up a bit, so we are over 10 degrees, and the knock amplitude values are not close to the limit during the whole sweep. So I can guess we can use more ignition timing also in the high RPM region as well.
Yeah, this is correct. Again, what you had mentioned is the MFV50 value is still not close to the ideal because, as you might remember, we mentioned in a previous video that the optimum of MFV50 is around 8 to 10 degrees after TDC. And the knock limitations are, rule of thumb, 1 bar per 1,000 RPM. So the red line for this measurement was set for 6,000 RPM, so we can go up to 6 bars. But we need to look at the average, not just the peaks. So you're absolutely right. Let's apply 1 degree of spark, basically through the whole region. And this is exactly what we've done from 3,000 RPM to the red line. Next one.
Yeah, so things are happening as we would expect. Knock peak is going up, but there are some peaks that are just crossing the limit, but the average is still not there. MV50 values are going down for the whole region. So I can guess that we just apply ignition timing for the upper region of the RPM curve, and let's see what's happening, because if we just take a look at the knock amplitude, we are just quite on the safe side.
Correct. So the average of knock is around 3 to 4 degrees in the top end. And as we mentioned, we can go up to 6. So let's increase the ignition advance at the top end, basically from 4,500 RPM till 7. Let's see what comes. The next one.
Yes, we are just getting close to where we want to get. But if you take a look, we could go even a bit closer to the ideal values, because the knock amplitude is going closer, what we just consider to be a borderline. But we are still not there. So if we are just a bit, just safely going a bit closer, then so just apply a bit more ignition timing than.
Yeah. So Bond is now talking about the 3 to 3,500 RPM region, basically here, because the knock is way below the limitation. So let's apply a bit more spark there, half a degree. And this is the final measurement.
Yeah, what is visible here, that we have some significant knock peaks in that region, and the average value is just close to the limit, what you have said. Yes, the MV50 value is getting quite nice here, but we just can't get closer to the ideal value because of the knock limitation. And at the top end, the values are just quite satisfying. So I can just say that we have just arrived to the point where we wanted to get.
Yeah, this is correct. So this is what's called minimum spark for best torque, but it's limited by knock. So let's see the results. Again, to mention, fixed lambda set point, and the ECU knock controller was turned off the whole measurement, but the set point, what has been used for the first measurement, was basically built with using the ECU knock limitation. So what we see on the graph is IMAP is significantly higher than before. The blue one is the new one, the orange one is the starting point. And it is very important that we added some spark, so we decreased the exhaust gas temperature, which also means that if we are looking for performance here, we can also lean out the engine a bit, which will give us a couple of Newton meters more. Efficiency is increased, obviously, because we got closer to the optimum MFB50 point. And what is also important to mention is that the cyclic dispersion is much lower, so the engine runs much more stable, which is also a benefit when you do run on the racetrack. So basically this is it, our little tuning tutorial. If you have any questions, feel free to go on our website. There's a contact us form, and send it in to us.
Make sure you subscribe to our newsletter in the link below to get all the relevant info and updates. And of course, the next sessions of the BDN tutorial videos. Get the most out of your engines and let's win races together.